Welcome back, students. In this lecture we will discuss how to calculate the static indeterminacy of trusses. Start with plain truss or 2D truss. So as we discussed earlier, the static indeterminacy is the sum of external indeterminacy and the internal indeterminacy. So the external indeterminacy is same as in the case of the plane frame, where external indeterminacy is equal to the number of reactions exceeding the number of available equation, which can be represented as ds is equal to r minus 3, where r is the number of unknown reactions. Okay, now in order to find out the internal indeterminacy, we have to know something known as stable or perfect truss, perfect plane truss. Okay, so it is to be understood that the simplest form of a perfect plane truss is a triangle, as shown here. Okay, so if you check this triangle, this is a perfect truss and it has three members, m1, m2, m3, and three nodes, n1, n2, n3. Nodes are something also called as joints. Okay, so now if you want to extend this truss by adding a new joint, say n4, we require two additional members. So using these two informations, you can calculate that for any perfect truss, the number of members m is equal to 3, which is the minimum for a triangle, 3 plus for each additional joint, that is for every joint exceeding 3, j minus 3, we require 2 additional members, so j minus 3 into 2. So if you calculate this, m is equal to 2j minus 3 is the equation for number of members in a perfect truss. Any number of members exceeding this 2j minus 3 is called as redundant members, and this redundant member is nothing but internal indeterminacy. So the number of redundant member is equal to internal indeterminacy. So we can express internal indeterminacy as dsi is equal to m minus 2j minus 3, where m is the number of members, j is the number of joints in the truss given. Okay, so now adding up both dsc and dsi, you can find out the value of total static indeterminacy of plane truss equal to r minus 3 plus m minus 2j minus 3, which is equal to m plus r minus 2j. So ds is equal to total indeterminacy of a plane truss is equal to m plus r minus 2j. Let's see some examples on plane truss. So we start with this problem. Okay, so this is a roller, which means there is only one vertical reaction here, and this is a hinge, which means we can have a vertical reaction as well as a horizontal reaction, right? Let's calculate the number of members. So 1, 2, 3, 4, 5, 6, 7, 8 and 9, right? And the number of joints is 1, 2, 3, 4, 5, 6, right? So putting in the equation t is total indeterminate t is equal to m plus r minus 2j, you get number of members is 9 plus reactions are total 3 and j is 6. So putting in the equation, you get t is equal to 0, and external indeterminacy you can calculate as r minus 3, which is again 3 minus 3 equal to 0, which means that internal indeterminacy equal to total indeterminacy minus external indeterminacy, which can be 0. Otherwise you can calculate I is equal to m minus 2j plus 3 also, right? Now this is another example. Here this is 2 hinges, so here you have 2 reactions, here also you have 2 reactions, right? And the number of members is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and the number of joints is 1, 2, 3, 4, 5, 6, 7, 8. So 8 joints are there, 15 members are there, and the reactions are 4. R is equal to 4. So substituting the equation, you get total indeterminacy is 3 and external indeterminacy is 1, which means that 3 minus 1, 2 is the internal indeterminacy. So this is a side mounted truss. Here you have a hinge, which means there is 2 reactions here, and there is a roller support here, which means that there is only one reaction here, a horizontal reaction, okay, perpendicular to the surface, right? Number of members is 1, 2, 3, 4, 5, 6, 7. M is 7. 3 reactions are there, and joints are 5, which means that total determinacy is static indeterminacy is 0. External indeterminacy is 3 minus 3 is 0. Internal indeterminacy is also 0. This is another equation. Here number of members is 6. Reaction 2 hinges, which means that 2 plus 2, 4 unknown reactions, and 4 joints. Please note this is not a joint here, it is just a crossing of member, right? This is another side mounted truss. You can see support, hinge support here, it means 2 reaction here, and a roller support, which means 1 reaction here. Calculate number of members is 11 in this case. Reaction is 3. J is 6 joints are 1, 2, 3, 4, 5, 6, right? External indeterminacy is 0 in this case, which means that the total indeterminacy 2 is equal to internal indeterminacy only, okay, which means that 2 members were redundant in this particular example. Now let's see some special trusses which are called as wall or roof attached pin joint trusses. The speciality of these trusses is that there is no support. These are directly attached to walls, and there is no support mechanism at the wall. As you can see in this case, the members are directly originating from the wall only. We don't have any supports here, like roller, whether it is a roller, whether it is hinge, anything. Okay, so what is special about this equation? This is that the external indeterminacy is 0, because once you know all the member forces, you can directly find out the reaction at wall support as opposite of resultant of the member forces at support. Okay, so if member force in this one was like this, the reaction at this point would have been opposing that. Okay, so for wall mounted trusses, external indeterminacy is always 0, and the internal indeterminacy DSI is given by m minus 2j, where m is the number of members and j is the number of joints. So seeing these examples, number of members is 1, 2, 3, 4, 5, 6. 6 members and 1, 2, 3 joints. So while calculating joint, please ensure that you exclude the wall joints. Okay, so only 3 is calculated. Here also 3 joints, and number of members is 1, 2, 3, 4, 5, 6, 7. So 7 minus 2 into 3, we get 1. Here 1, 2, 3, 4, 5 members are there, and only additional 1 joint is there. Okay, so 5 minus 2 into 1, which means 3. Now let's see how to calculate for space stress. So space stress also, the external indeterminacy is same as the space frame, which is ds is equal to r minus 6, because there are 6 number of available equations. And the simplest form of a stable space stress is a tetrahedron. So tetrahedron, we can also think about it as a triangular pyramid. So for it, imagine a triangle pyramid which is having 4 triangle sides. Okay, so thinking about that, it has 6 members and 4 joints, and if you want to add an additional joint to that, we require another 3 additional members. So in that case, the number of members in a perfect space stress can be calculated as m is equal to 6 is the minimum number of members required, plus every additional joint, which is joints exceeding 4, j minus 4, we require 3 members, so 3 into j minus 4. So calculating that, we have m is equal to 3j minus 6. So any number of member greater than 3j minus 6 is called as redundant member in the case of a space stress, and that is nothing but internal indeterminacy. So internal indeterminacy can be expressed as m minus 3j minus 6. Okay. Now calculating the total indeterminacy, ds is equal to r minus 6 plus m minus 3j minus 6, which is equal to m plus r minus 3j. Please note, earlier for static truss, plane trusses, ds was equal to m plus r minus 2j. Here it is m plus r minus 3j. Now let's see an example on space truss. So here we have 6 joints A, B, C, D, E, F. So number of joints is 6. A, B, and C are pin joints in space, which means that there are 3 reactions at each of the hinges: a horizontal, vertical, and 1 horizontal, 2 horizontal, and 1 vertical reactions. So here also 3 reactions in X, Y, and Z. Right, here also 3 reactions X, Y, and Z. So total number of reactions is 9. Number of members, 3 vertical members, then 3 horizontal members at the top, and 2 number of braces, diagonals in each of the sets, which means 2 into 3 plus 3 plus 3. Total 12 members are there in the case of this particular example. So substituting, T is equal to m plus r minus 3j, which accounts to 3, and external indeterminacy is also, if we calculate r minus 6, so 9 minus is 3, which means that internal indeterminacy is 0. So that's it for today. In next lecture we'll see how to find out the stability of a structure.